Support comes from St. Louis Public Library Foundation, helping the library serve children and their families with programs and services needed to become lifelong readers. More information about the foundation is at slpl.org.
This is St. Louis on the Air from St. Louis Public Radio. I'm Elaine Cha. Last month, NASA launched an approximately 13,000-pound spacecraft to begin a detailed study of Europa, Jupiter's ocean moon. That massive probe is on a mission to help scientists develop a better sense of the moon's structure, what materials may exist within it, and whether it could sustain life. William McKinnon is a professor of Earth, Environmental, and Planetary Sciences at WashU. He has studied Europa for more than 40 years and is a member of NASA's Europa Clipper science team. We're happy to have him on the show to share more about his work and hopes for this Jupiter moon mission. Bill McKinnon, welcome to St. Louis on the Air.
Oh, thank you. It's wonderful to be here.
So, Bill, you were at the launch at NASA's Kennedy Space Center in Florida last month. What was that like? What did you see?
Well, as you might imagine, these sorts of things are very exciting, and there's a huge buildup that goes on for months, if not years. And then it got a little bit more exciting than we wanted, because when we showed up, we knew that there was a hurricane buried down on Florida, and it managed to pass over Cape Canaveral, the launch site, at almost the exact moment we were planning to originally launch, which, of course, is not a good thing. Mm-hmm. Although some people suggested, why don't we just wait for the eye to pass over, and then we could shoot up through it. But that's kind of crazy, because the winds come in and the winds go out. So the spacecraft was put away safely, and so the launch was delayed for several days, but once the Hurricane Milton passed by, it was beautiful, clear blue sky, and it was a fantastic moment.
Yeah, so memorable and on many counts then.
On every count, because, living through I've lived through hurricanes before.
Right.
And, but this one actually brought a tornado that actually clipped our meeting hotel and everything.
Oh, my goodness. So, Bill, as we mentioned in the introduction, it has been more than 40 years that you've studied Europa. How, in that time, has our understanding of that particular moon of Jupiter evolved?
Well, it's like, for me, the journey really started, back when I was in school, and NASA's Voyager missions, which were these first probes to really pass through the outer planets and just see what was there. And so it revealed that Europa was a very special moon, even among all the other moons in the outer solar system. Mm-hmm. Hardly any impact craters, completely covered in ice. And we began to suspect that maybe underneath that ice would be water. Mm-hmm. But that was only confirmed when NASA sent another probe back to the Jupiter system in the 90s called Galileo, which it didn't go to Europa specifically, but went to all the moons in various, configurations. And we saw fantastic images, and we gathered up magnetic field data that really indicated that there was this conducting layer, that is electrically conducting layer hiding beneath the ice. And ever since then, we've been, the scientific community, people, space-interested people, we've been itching to go back to Jupiter and really examine Europa as best we can to, really kind of, like you were introducing, trying to establish what are the conditions there, and could these conditions be conducive to even the most simple or primitive life forms? Mm-hmm.
Can you briefly describe what some of these images look like?
Well, if you look down, you see basically an icy plain covered in ridges, and then you see broken ice blocks that seem to be frozen in place, like in a mush that you might see in St. Louis in the winter on the road.
Oh, right.
And it's as if the parts of the shell break up and refreeze, a bit like the Arctic Ocean, if you think of images of ice flows and bashing into one another. So we know there's internal activity. And ice is ice, but Europa is discolored in these places. It's sort of brownish or reddish. So there's something there that is not ice, and we think it's different kinds of salts, which come from the ocean.
Mm-hmm. So internal activity? Tell us a little bit more about that.
Well, Europa it's a little bit smaller than our own moon, but it's an active world. and I mean geologically active. And so it has the benefit of something we discovered in our space exploration, that worlds can remain warm and toasty, if you like, on the inside due to tidal squeezing, not just, the decay of radioactive elements like we have on the Earth. So that Europa is in what we call a gravitational resonance with two other moons of Jupiter, and it's continually bent back and forth. If you take a paper clip in your hand and you bend it back and forth and then touch it to your skin, the hinge, it'll be hot. And that's what's happening inside Europa. And it keeps, basically, it sustains an ocean far from the sun. I mean, it's a whole revolution in how we think about where life could even be. Like in the old days, right? The old days, we'd say, it has to be a planet close to a star so it's warm on the surface so we can have an ocean like we have.
Right.
But out there in deep space, it can be cold on the outside and warm on the inside. And since water is denser than ice, as we all know, the ocean can hide. And, who knows what's swimming down there.
Right. So are these factors then what has contributed to this mission to this particular moon, Jupiter, instead of going somewhere else?
Yeah. Well, we've actually learned that there's probably more than one moon in the outer solar system has an ocean. There's a moon of Saturn, that's even smaller than Europa, called Enceladus. And this one is actually spouting water vapor and salty particles into space because the gravity there is so low. And it also benefits from a tidal squeezing source of heat. And so and we suspect some other moons also have internal oceans, but they may be locked away at great depth. So Europa is one of the key places in the solar system to assess habitability, to really see what the limits of possibilities are for life.
So is habitability then the question at the heart of this mission?
Absolutely, yeah. That's our mantra, is to explore Europa, which is what we are going to do with this mission when we get there, and to assess its habitability. We're not. NASA likes to say we're not looking for life itself, because we don't want to overpromise, but we want to see what do the conditions truly merit, let's say even further exploration later in this century.
So what effects would an answer to this core question then have on science and perhaps even on society?
Well, we would look at it as like this is an alternative arena for, the evolution of life. And if we could actually detect such a thing, it would really tell us about in a sense, the possibilities for life elsewhere in the universe. I mean, we have this idea that the universe is so vast and there's so many stars and so many planets that out there somewhere there has to be something. But we don't really know. We have no evidence for any other living worlds.
Right. Do you have any guesses, Bill, about what you may find, or maybe wishes for what we may find?
I am wishing that we can actually find places in the ice shell that are thin enough that we might consider in the future going through it with some sort of robotic machine that could actually melt its way through the ice shell and get into the ocean and basically go around and explore. And one of the things that we're carrying on this mission, the Europa Clipper, it's what's called a sounding radar. You might think of radar for detecting planes or, raindrops, but this radar can see through cold ice. So the idea is that we'll be able to look inside Europa. Actually, it's like an X-ray,
right.
Tomography of the shell, the icy surface, and we'll see where that ocean is. We'll see if there are any lenses or other bodies of water which are theoretically predicted to be possible inside the Europa shell.
You worked on several instruments on the probe as part of the science team. What are those instruments, and how do they work? You
want to know about my instruments or all? Okay, all right. Well, I just mentioned the radar.
Right,
okay,
right.
So we're going to look through the shell and hopefully see the ocean itself, see to the bottom of the shell. Another one is called it's a mass spectrometer. And that is because we are flying, we're not going to land on Europa, we're not even going to orbit, but we're going to keep going by Europa repetitively again and again at different latitudes and longitudes and altitudes. And one of these gizmos is a mass spectrometer to literally determine the chemical composition of molecules that get kind of chipped off the surface by micrometeorites and so forth. There's a kind of halo of stuff around Europa, and we'll be able to really buzz the surface and determine exactly what the chemical composition of the surface is. And we know there's water ice there. It's the other stuff that we're interested in.
Right.
And especially if any of it is organic in nature, which would be very, very interesting.
So how would that work? I mean, to collect those molecules without landing, like how close will that probe get?
We're going to fly as close as 25 kilometers, or if you like, 16 miles off the deck. And there's actually two instruments, one the mass spectrometer I'm involved with and a dust analyzer, which is a separate mass spectrometer. So they're both physical bits that get blasted off and then individual molecules and atoms. So we're going to get a good chemical sense. You know, it's kind of like taking a bloodhound.
Oh, I see. We're speaking with William McKinnon, Bill McKinnon, who is a professor of Earth, Environmental, and Planetary Sciences at WashU. He's part of the NASA Europa Clipper science team, which has sent out a massive spacecraft to study Europa, which is one of Jupiter's moons. So, Bill, there has been some recent research that casts doubts on hope for life on Europa. Paul Byrne is another WashU planetary scientist who's part of this Europa Clipper science team that you're on. And he said that even if life did arise in Europa's ocean long ago, that it seems challenging that it would sustain life today. And it's because while there may be molten rock deep inside Europa, it seems difficult for that magma to be able to, to go up anywhere else close to the ocean floor. What do you make of that?
Well, Paul is a colleague of mine at Washington in my department. We have a friendly disagreement over this topic. Okay. No, my view is that magma will out, or magma will find a way. On the Earth, we have the great advantage. We have this, this cycle we call plate tectonics, where there's a lot of activity that breaks the crust up and allows magma to, arise. We have volcanoes in all sorts of different places on the Earth. But even on worlds that are smaller and don't have this kind of plate tectonic cycle, volcanism works, or has worked in the past, like on the Moon and on Mars, on the planet Mercury. So I'm confident that magma can reach the seafloor, but the whole point of the mission is to find out these sorts of things. And one of the other experiments that I'm involved with, the third one that is the gravity experiment, which is not a separate instrument, but we just use the Doppler tracking of the spacecraft, just the way, police radar guns work. We're going to, measure the change in velocity of the spacecraft as tiny incremental changes and determine if there are basically submarine volcanoes on that seafloor. We're going to be looking for them.
And just to make a clarifying point, Paul Byrne, is he part of the team or he's written recently?
He's an independent researcher. He's not formally affiliated with the team. But in fact, we are working together on this project.
Right. Yeah. Do you have a bet going?
No, but that's a great idea. But I'll take him up on that.
Sure. So the spacecraft, talk with us about the trajectory of it, because it's not going, just in one direction and continuing that way. Talk about that, Bill.
Oh, okay. Because we want to go into orbit around Jupiter, we don't want to get there going too fast. And so even with the most powerful rocket that we can use right now, which was the Falcon Heavy that we launched on last month, we can't get all the way to Jupiter. So we're actually going to Mars first. A nice place to visit. But we're not staying. We're just flying by. We're going to get there in February, so that's how fast we're going.
Okay. Wow.
And then we're going to actually loop back to the Earth and use the Earth. In both cases, both Mars and the Earth will add a little bit of gravitational assist and speed our spacecraft up. And so we'll come back in 2026 to the Earth, and then we'll zoom out to Jupiter and get there in April of 2030.
It sounds very much like science fiction, like to imagine that this is actually going to happen.
Well, we worked for a very long time to make this dream a reality, because ever since we saw those fantastic pictures of the broken up ice shell on Europa that I was telling you about, we've been working to figure out the best way to do this kind of exploration. I think we've hit on a really great scheme.
Right. I mean, are there any concerns about things that could go wrong? I mean, there's a lot of time between now and 2030.
Yeah. Well, I like to say that the spacecraft is now in flight. It's in its happy place. It's designed to be in space. It's much better to be in space than it is in a warehouse with the oxygen atmosphere that we have and all that kind of stuff. Things can go wrong and often do go wrong with spacecraft, but we have a lot of redundancy built into the spacecraft. And, some people may have read that over this almost leading up right up to launch, we were very concerned about certain transistors that are basically on-off switches within the spacecraft, whether they would be as resistant to radiation, because there's intense radiation near Jupiter, like the Van Allen belts that surround the Earth, but at Jupiter they're on steroids. That's basically
right.
And massive amounts of testing at the Jet Propulsion Lab in Pasadena and other places have convinced us that we can manage the environment. And but we go forward with things we want to do. Like recently, we had our first trajectory correction maneuver, as we call it. That means we fired the engines.
Okay.
And that worked perfectly. And one of the other instruments to detect magnetic field changes near Europa. The magnetometer is on this long boom. It's like a giant slinky that goes out. It's 8 meters long. And it deployed successfully. And today, some of the radar antennas are going to go spring. And I'm waiting to hear if it works.
Okay. Do you get alerts then each time this happens?
We get daily updates.
Okay.
About
maybe
what's going on.
Alerts are not a good way to put it.
It's like usually a long list of all the stuff, and everyone so far has been green and nominal. Those are the magic words we like to hear.
Okay, green and nominal. So this mission, the Europa Clipper mission, costs $5.2 billion with a B dollars, and as far as NASA missions go, I mean, is this one of the larger ones? And what is the justification for that $5.2 billion price tag?
Well, it is a major NASA mission. It's probably the most complex planetary mission that NASA has launched. It's not as expensive or complex as, let's say, the James Webb Space Telescope that folded out like an origami in space a couple of years ago. It's the way NASA runs things is that most missions are much less expensive and they have a higher cadence. But every so often, you need to really do the job right, and the resources are put together to accomplish a great goal, and that's what this mission is going to do.
Yeah.
And I will say that the 5.2 is that's soup to nuts. So that's from the very beginning to the very end of the mission in, let's say, 2035. So
yeah. It's
any given year. It's not as much.
Right.
And I would say probably most of it's already been spent building the spacecraft and buying the rocket, and then launching it. So now it's just we get to operate it.
There is a partner on this. SpaceX has partnered with NASA for this mission. What is the significance of that, Bill?
Well, it's that they had the best rocket for the job. For a while, we were thinking about using the Space Launch System, which is a NASA rocket under development for mostly lunar missions. But this is a massive rocket that would have taken us directly to Jupiter, no pit stop at Mars. But it turns out its development has been delayed, and also the environment was the vibrations were so intense that it would damage our spacecraft. So we went with SpaceX. And they do a lot of launches for NASA and for the Defense Department.
Right. So this mission, if it does find that Europa has those conditions that are favorable to some form of habitability, what comes after that?
Well, just to back up a bit, it's like, we know there's water there, but the question is, what is the composition? We want to know what the composition of the ocean is. We want to know, is it a an environment suitable for at least life as we know it. You know? And if that turns out to be the case, it'll be up to future generations of people, young people, both here in the U.S. and maybe abroad, to what would be the next step. So we'd be flying by it. So the next step would be to obviously go to the surface and try to do some sort of direct analysis of materials that maybe recently erupted from that ocean. And like I said, like the ultimate dream, of course, is to send basically a submersible that would actually pilot itself through the ocean doing exploration. It's like that's more science fiction at this point.
Oh, right,
But,
right.
you know, who knows what could be accomplished later this century.
Well, I mean, without imagination, where we would go.
No.
Right? And does it seem that there is a certain level of interest in this particular mission that points to, you know, people continuing to invest their imaginations and their times and talents into continuing this work?
I would say so. When we first learned about Europa, very few people even thought about the moons of Jupiter, except maybe a handful of astronomers. But now a lot of people know that in fact there are these environments, and that there's it's a much broader palette out there in space. And people know that we've discovered thousands of planets around other stars. We don't know much about them. We haven't discovered their moons yet, but they must have moons as well. So it's I don't know. It's just a wonderful thing to think about.
How does that affect the way that you look at this world right now?
Well, I mean, if you look back on it, it's still Europa or Mars or any of these places are still much less hospitable than our own wonderful planet. We like to say that Europa is an ocean world, but of course, the ultimate ocean world, the original, the OG, is ours, right? So that's
as far as we know.
Yes.
So you've been studying Europa, Bill, 40 years plus.
Yeah.
So this mission has been in the works for decades. And as you said, it's going to take until 2030 for the Europa Clipper spacecraft to reach Jupiter. And you're talking with us now about the probe's launch, and that in itself is an achievement. But what does it feel like to see this mission come to fruition?
Well, obviously, it's wonderful to see it launch, but the true payback, or payoff, I should say, will be when we get there. Because once we get there, it'll be an incredible amount of data, because we're going to be flying close to Europa dozens of times, maybe many more times if we get an extended mission. And frankly, waiting 6 years is not so bad.
Right, compared to 40 plus.
To 40 plus. But also, I was part of the New Horizons mission to Pluto, and we launched, and it took 9.5 years to get to Pluto, and that was a whiz-bang of an encounter.
Yeah. Well, I heard you say elsewhere that you would be twiddling your thumbs until 2030, but really, what will you be doing until then?
Well, we're making detailed plans for the observational, the details of each observation. We look at every flyby of Europa, and in fact some of the companion moons that are part of the overall trajectory. And we'll be doing some theoretical models and just getting ready to analyze the data when it comes in.
Right.
And twiddling the thumbs is kind of an exaggeration.
Of course.
But mostly we are waiting. Right. We won't have any. It'll be an incredible frenzy of activity when we get there for several years.
Right, right. Well, I'll look forward to talking with you in 2030 about this. Right. William McKinnon is a professor of Earth, Environmental, and Planetary Sciences at Washington University. He studied Europa for more than 40 years and is a member of NASA's Europa Clipper science team. Thank you so much for joining us today.
Oh, wonderful to be here. Thank you, Elaine.
This episode was produced by Emily Woodbury.
Audio engineering and podcast design by Aaron Dorr.
Our executive producer is Alex Hoyer.
St. Louis on the Air is a production of St. Louis Public Radio. Understanding starts here.
Do you find yourself regularly listening to episodes of St. Louis on the Air? Suggest us to a friend you think might enjoy our conversations. And leave us a review and rating on Apple Podcasts on the App Store. It's the simplest way to help people discover our show. Thanks.
St. Louis Public Radio is a member-supported service of the University of Missouri St. Louis.
The Gateway brings you the day's news each weekday from around the St. Louis region and the state capitals in Jefferson City.
Our schools are accredited. We don't need this bill.
And Springfield.
How many more years must pass before lawmakers see time is of the essence?
I'm Abby Larico. Join me each weekday for The Gateway on the STLPR app or wherever you get podcasts.